Hello, Dr. Venn-Watson. You are a co-founder and CEO of Seraphina Therapeutics. So welcome to Modern Healthspan, and thank you so much for joining us today.
Well, thank you, Richard. It's wonderful to be here.
Thank you. So you've been studying fatty acid, well, C15 in particular, and its relation to human health. So where did you first encounter C15 and see that it was so relevant?
Right. Well, so our discovery of C15 as a beneficial, just being an active and beneficial nutrient, came as quite a surprise. It was an accidental finding. We didn't have a study with a hypothesis of C15 is going to be beneficial. To be honest, had never even heard of this nutrient. I am a veterinary epidemiologist, and I was working with the Navy's marine mammal program. I was brought in I was previously at the CDC, World Health Organization, and was brought in to help understand healthy aging and dolphin population health at the Navy's marine mammal program. Navy has cared for a population of sustained population of about 100 bottlenose dolphins for over 60 years, so a long time. So they had accumulated a lot of data over that time, enough to bring in an epidemiologist, right, to go through the data and understand health and wellness of Navy dolphins. Now, because the Navy takes such good care of their dolphins, they live in the open ocean, go out in the open ocean every day they choose to come back. Because of their really good care, Richard, they live a lot longer than in the wild. So in the wild, they live to about 20 years old. At the Navy, they're living routinely into their 40s and 50s. And now I just heard even into their 60s. And what we learned over a period of a decade is that dolphins, as large-brained, long-lived mammals, age a lot like us. We saw a subset, about 1 in 3 of older dolphins were developing high cholesterol, chronic anemia, chronic inflammation, and even seeing changes consistent with the full suite of changes in the brain consistent with Alzheimer's. So we had the good fortune of having Office of Naval Research funding dedicated to understanding this subset of what appeared to be more of kind of accelerated aging dolphins versus healthy aging dolphins. We used an advanced technology called metabolomics, and we studied thousands of small molecules present in the dolphin's blood in their all-fish diet. And Richard, what we found at the end of the day, because this was untargeted search, so we were looking at over 400 different molecules specifically. And while we had expected that omega-3s would predict the healthiest aging dolphins because all they eat are fish, instead, what we saw at the top of the list was this molecule called pentadecanoic acid, otherwise known as C15, predicted the healthiest aging dolphins. So that's what really kicked off the whole exploration on our side.
Interesting. So did you look at kind of previous? So you saw that in the dolphins, it was correlated with health, but better health, having higher C15 levels. And this is in the blood plasma, right?
That's right.
Right. So did you have a look at previous human research and how did that kind of correlate with what you were seeing in the dolphins?
Well, we did. It's a great question. So, as we started turning our attention on C15, we looked at the existing literature, and that's where we found, lo and behold, there was this whole subset, right, of studies of large-scale population studies showing a similar thing that we found in dolphins, that people with higher C15 plasma levels or serum levels were less likely to develop diseases like type 2 diabetes, fatty liver disease, and heart disease. So it was wonderful to see a similar trend. Interestingly, those papers, even though that had been published, those findings were buried in a lot of the papers because the intent of those papers were to show that saturated fats are bad for us. This is a good time to mention that C15 is an odd chain saturated fat. So the papers were done to show that saturated fats were bad. And they did show that. They showed that these even chain saturated fats like C16 and C18 were correlated with poor health. And then it's kind of like written as a PS at the end of it. And oh, by the way, we found these odd chain saturated fats, C15 and C17, had the opposite effect. but it was almost kind of like it didn't fit with the hypothesis. So they mentioned the discovery, or I should say the discovery, they mentioned the correlation, but they didn't really do much with it. So it wasn't until the dolphins brought our attention to it that we moved C15 into the lab, Richard, and said to test, is it not just associated with better health, but is it the cause of that for both dolphins and humans?
Right. So I think now would be a good time to discuss. So what is the difference between an odd chain fatty acid? And so, but all of these are saturated. We're talking about saturated fats. What is the difference between an odd chain and an even chain fatty acid? Why do they have different kind of metabolic outcomes?
Right. It's kind of crazy to think about it, right? That how is nature taking just all the difference is just one carbon, and it's either like goes to the dark side or to the light side. So if we talk about fatty acids in general, we have saturated fats and unsaturated fatty acids. So within the saturated fat class, they're named so because it's basically a straight chain of carbons that have no double bonds. So double bonds are great for flexibility, but they're also weak points to get attacked by oxygen and set up lipid peroxidation and those negative processes. So within the saturated fats, the number of carbons, whether they're even number of carbons or odd, determines whether it's an even chain saturated fat like C14, 16, 18, versus an odd chain fatty acids, primarily C15 and C17. So now we have, right, the understanding that odd chains are consistently associated with better health, even chains with bad health. So the question is how and why? And so what's been shown is, and what we've been able to demonstrate along with others, is that even chain saturated fatty acids are reliably pro-inflammatory. So they've been used, C16, for example, is a classic molecule that's used to induce inflammation in mice and cell systems so that it can get fixed by drug X, Y, or Z. So it's long been known that that even chains, especially C16 and 18, are pro-inflammatory. We also know that when our bodies metabolize saturated fatty acids, they always reduce it by 2 carbons. So it means that if you start as an even chain saturated fat, like C16, you're going to go to C14, C12, C10 as you get metabolized. So you will always stay an even chain saturated fat all the way down to the final metabolite, which is acetoacetic acid, which is a pro type 2 diabetes and inflammatory molecule. On the flip side, odd chain fatty acids always stay odd. Their final metabolite is propionic acid, or C3, which has long been known to have beneficial properties. More importantly, C15 itself, among all the different odd chain fatty acids, is directly anti-inflammatory, and it does so in a dose-dependent manner and better as a Goldilocks one than any of the other saturated fats.
So the other thing is that there's, as a percentage of fat, there's far more of the even chain than the odd chain. The odd chain make up like 1 or 2% or something like that. Do we know why that is?
Right. It is just an unfair fight. So we have this, which is a big reason why C15's been hidden as this good. And now, as we published with Dr. Ed Dennis, a leader in fatty acids and scientific reports back in 2020, that C15 is the first essential fatty acid to be discovered in over 90 years. So it's been right in front of us all along. We've known about C15, the world has, since 1954. But because, just like you're saying, Richard, because it's present in such low levels, it was always just written off as it can't be that important because, like you said, it's only 1% of milk fat, while C16, C18, the even chains are more than 40% of milk fat. So it really took the dolphins to teach us that we need very little amount of C15 for it to do its job. And we can talk about all the heavy lifting it does, but it's really, we only need about an added 100 to 200 milligrams of dietary C15 a day to maintain our baseline health, primarily through activating receptors and, most importantly, keeping our cell membranes strong and resilient.
Yes, definitely want to get into that. But before we go there, where do we get C15 from? Where did we get it from historically? Where is it available in the food chain?
So this also becomes another big unlock for us, right? So C15, our primary source, so it's essential fatty acid, which means that our bodies don't make enough of it, that our bodies need certain levels of it for us to maintain our health. And if we don't get enough of it, we'll chat about that. But our bodies don't make enough C15 on their own to reach those essential levels. Therefore, we get it from our diet. By far, in Western countries, the highest, most reliable source of C15 has been dairy fat. And as we know, since 1977, we've been told to avoid and decrease our intake of all dietary saturated fats. C15 came along with that ride. And as we've decreased our intake of dairy fats, especially whole fat milk and cheese and butters, that has led to population-wide decreases in C15 and the health consequences that come with it. So dairy fat by far is our primary source of C15.
What is within dairy? What would be the best kind of source of C15 if you could get full fat dairy?
Right. So there have been a lot of studies looking at doing fatty acid profiles on foods. And to what you're getting to here, Richard, is like there's variation in dairy fat. Even if you look at whole dairy fat products, there's variation in C15. Even if you look at, so traditionally, up until recently, butter is your most dense source of C15. And that's where it can be, again, it's about 1%. It's still only 1% of fatty acids in it, but that amazingly is a rich C15 rich source. What we've learned is that it can vary, C15 levels in dairy fat can vary based upon what the cow was fed. So if a cow is fed a whole or is grass fed, it will have twice as much C15 in it as a cow that is fed corn. So going for that grass fed dairy products will result in a higher C15 level. Of the different dairy fats, really what's emerging are hard cheeses. So a big hint came from Sardinia, this longevity blue zone, where that's specifically where more men live to 100 than anywhere else in the world. They have, in general, I should say, in the world generally, including in the US, the average C15 level is about 0.2% of our fatty acids are C15. So today, in our kind of C15 deficient-ish food world, we have an average of about 0.2% in our blood. Sardinians have 0.4 to 0.6%. So they have 2 to 3 times higher C15 levels in their blood. And when you look at their diet, they have goats and sheep that are grass-fed. They're locally grown. They eat mountainous grass. There's studies even showing that the higher the altitude that an animal eats the grass, even higher C15 than low altitude grass. And the cheese that they make is called pecorino, which has almost twice as higher C15 levels than even butter, which was previously seen as the king or queen of C15 sources. So I would say, that was a long way to answer, but I would say probably a pecorino cheese or cheese coming from a grass-fed mountainous ruminant.
Right. So a ruminant is the key thing, right?
That is right, yeah.
So it doesn't have to be cow, but it does have to be a ruminant.
Exactly. Yeah. And I think that if you put cows in Sardinia up in the mountains and let them eat that grass, I would venture to guess that their dairy fat would be just as high in C15 as their goats and sheep.
So in Asia, people don't drink. Well, they don't eat dairy very much. So I just wondered, I mean, historically, do we know where the people in Asia got their C15 from? Was it from
right?
fish?
So I had that same question because I'm half Chinese.
Right.
And my dad is Chinese, and he wasn't prior when he was growing up, not a big dairy eater. And that's where the dolphins get back to telling us about alternate C15 sources for other parts of the world. If you break up the world, we're either dairy consumers, heavy dairy consumers, or fish consumers. And so dolphins were getting their C15 from specific types of fish. So not all fish have C15 in it. Of the fish that have C15 in it, the highest C15 concentration is in the skin and the heads of fish. And so if you look at a lot of cultures, traditional Asian cultures or island cultures that may not eat a lot of dairy products, they do eat whole fish. And in fact, I remember that the person of honor at the table, the eldest person, you would save the fish head for that person at the table. And little did they know that it was in part by you're giving them a giant dose of C15. So, and then as the same thing has happened in Western cultures where we've moved away from dairy fat, a lot of Eastern cultures where fish used to be part of the diet as many as 3 times a day, having fish as part of the cultural diet, they've been moving away toward these Western diets and away from their traditional C15 sources. So that was the dolphins kind of gave us a hint that there are different ways for cultures, but you'd have to eat specific parts of the fish and routinely.
Right. Interesting. Yes. Yeah, certainly in China, it's like eat everything, all
Right.
parts of
Yeah.
all parts of the animal.
You eat it, you eat it all. And that
Yeah.
for the fish, at least, that's where their C15 was likely their primary source.
Time flies. It's almost the end of 2024, but it's never too late to prioritize your health. There's still plenty of time to make a positive transformation before the new year. Every little step counts. Did you know that eating healthier can lead to notable results in just 1 to 2 weeks? Regular workouts can make a significant difference in 8 to 12 weeks. And improving sleep quality can be felt in as little as 2 weeks. A basic nutrient like magnesium is crucial for overall health. I personally use Magnesium Breakthrough by BiOptimizers. More than just a supplement, Magnesium Breakthrough is a comprehensive formula containing 7 forms of highly bioavailable magnesium. It's scientifically designed to improve sleep quality, enhance workout recovery, and boost muscle growth. Imagine the progress you could make in the next 90 days. We challenge you to make the most of this time. Combine Magnesium Breakthrough with your health and fitness efforts and see how far you can go. To help you get started, BiOptimizers is offering a special 10% off Magnesium Breakthrough when you use the code MODERN10 at BiOptimizers/modern. Don't let another year pass without reaching your health goals. What is the function of C15 in the body? So you talked about strengthening cells. So could you talk a little bit about how that works?
Yeah, absolutely. It's wonderfully simple. So I love when science, so nature delivers this very simple, literally 15 carbons, chain fatty acid, like I mentioned, has no double bonds, so that it is very sturdy. Every time you put a double bond into a fatty acid, it's a bending point. Like I said, it's also then susceptible to attack by oxygen. So because C15 is just straight 15 straight carbons and no double bonds, think of it as a brick. And so it is very stable in the bottle. Like if you take pure C15, it's not going anywhere. Like you can put it on a shelf for 5 years and nothing's going to happen to it. Same thing in our bodies. It's able to go into our cell membranes. Our cell membranes are made of 2 layers of lipids, and which are consisting primarily of fatty acids. And so the more C15 you have in your cell membrane, the more stable it is. And it stabilizes it specifically because it doesn't get attacked by oxygen. So it really helps to protect our cell membranes, decreases its risk of having premature death due to the lipid peroxidation process. So it's a really simple mechanism on that cellular strengthening. And that's where we've learned we need at least and really more than 0.2% of fatty acids in that cell membrane needs to be C15, otherwise it becomes fragile. So that's its probably most special role, and then we could talk about some of the other mechanisms of action as well.
Interesting. Yes. So, I mean, I know that omega-3 kind of has the opposite effect because it has this kink. It makes the cell membrane more fluid, but that can also be positive. So I assume you have to have like exactly, well, not exactly, but you have to have the right mixture to get the right level of stability and fluidity in the cell.
Yeah, you nailed it. Yeah, that's exactly it. It's all about, and in the end, it always comes down to it's about the right balance. And as we get older, even though we have the same amount, we tend to have the same amount of polyunsaturated fatty acids like omega-3s in our cell membranes for whatever reason, probably because we have more likely have underlying chronic inflammatory processes happen. Our cells become more and more susceptible to that attack by oxygen, to that lipid peroxidation as we get older. So being able to shore up and get that balance up, because as we get older, C15 levels also naturally decline. So being able to keep that balance of fluidity and resilience is really important.
Is C15 liquid at room temperature or solid?
Solid. It's a
Is that
solid white powder. Yeah, and it proves itself out just by sitting out on a desk that it will not go bad in your body. Its job is really to keep us
right?
stable, keep ourselves stable.
Yes. Okay. Yeah. So what other functions does C15 have apart from stabilizing the cell structure?
It's been pretty I have to say, I continue to be surprised by how much C15 does. Nature has put this molecule to work for sure. So we have, through the work, through our studies, but now through many others, there are over 100 peer-reviewed publications on C15 and its benefits, whether it's epidemiological studies, mechanisms of action at the cellular level, or now clinical trials. They all consistently point to C15 as having this pleiotropic role. And again, as an essential fatty acid, nature wants something to be pleiotropic, which means it does more than one thing. So in addition to stabilizing the cell membrane, we know that it repairs mitochondrial function. So if you give a cell that has impaired mitochondria, it actually helps the mitochondrial function come back. It helps to restore broken mitochondria. We know that it activates key mechanisms and receptors, things called like AMPK, AKT, and PPAR alpha and delta. And all of these are known receptors to help keep our metabolism, right, balanced and responding properly, glucose metabolism, insulin sensitivity. It also inhibits bad receptors. So it inhibits JAK-STAT and HDAC6 and mTOR. So it really plays this role of, if you look at the longevity regulating pathway, it feels like this pathway was just kind of built in part around C15 serving its role of helping the longer lived mammals like humans and dolphins live longer. It's a very humble molecule who does a lot of work specifically in the role of helping to stave off, again, keep us healthy for as long as possible.
Yes. I mean, and that kind of goes back to seeing these correlations with cardiovascular disease and type 2 diabetes that we kind of discussed before. So if you have, so what are kind of the impacts of having low C15? And so you kind of mentioned low C15 as being less than 0.2%.
Yeah, really low, right?
So is this measured again in the serum, or is this measured in red blood cells? Or
It's a good question because there are a lot of studies that have been done now on measuring C15 levels, and sometimes it's serum, sometimes it's plasma, sometimes it's the red blood cell membrane, or they'll call it the erythrocyte membrane levels. when we look at the percentages, it's remarkably consistent. So it kind of gets back to it's, in fact, the C15 is so consistent at within this kind of tight range that, for a long time, C15 was used as a biomarker to measure other fatty acids, because they knew that C15 was always going to be somewhere between 0.1 to maybe 0.5%. And so a lot of C15 wasn't actually included in a lot of fatty acid studies because it was used as the marker to measure the other ones. It's another reason why C15 didn't really come out, wasn't understood for its beneficial properties, because it was unfairly kind of put into the timeout box to help the other fatty acids get measured. So anyway, nonetheless, 0.2%, whether it's serum, plasma, or erythrocyte membrane levels.
Okay, across all of them. Okay, so what is the impact that we might see if we have insufficient C15?
Right, so this is a fascinating story. In the dolphins, we saw a very specific phenotype of disease popping up in, like I said, about a third of the older dolphins. We were seeing one of the first things we saw was, it's not like you're looking at a sick dolphin. It was caught just because they had routine blood samples taken. And we had the good fortune of the Navy keeps the tissues of all the dolphins when they pass. So we were actually able to go back into the archives and look at tissue samples. So the first thing that really popped out were elevated liver enzymes, ALT, AST, and GGT. We were seeing phasic increases in these liver enzymes, which were an indicator that something was happening with their liver, but it would come and go. And then they'd be fine. And then all of a sudden you catch them on this phase. Yeah. So we were like, well, so we went down the rule out list of parasitic, toxic, viral, bacterial, kind of went through the whole rule out list, and we got down to metabolic, because we were seeing that these dolphins also had high insulin levels that were consistent with developing insulin resistance. When we looked at liver tissues under the microscope, we were finding that they had fatty liver disease. And then paired with that, high cholesterol, some had elevated glucose. And so it was really looking like the combination of metabolic syndrome and fatty liver disease that was emerging in fatty liver disease showing up in humans, right? So fatty liver, non-alcoholic fatty liver disease, or now called MASLD. Well, it's going through a rebranding situation here, which I think is harder to describe than NAFLD. But there were no cases of NAFLD in humans. The first cases were identified in 1980 by Mayo Clinic. Today, 1 in 3 people have NAFLD, 1 in 10 children globally. So we were seeing at the same time NAFLD was increasing in people, we were seeing this emerge in the dolphins. The last piece that was really critical to the puzzle was that when we looked at the liver tissue, Richard, we were seeing iron deposits. So we were seeing iron overload in the dolphins. And when we measured an index of tissue iron overload called ferritin, we found extraordinarily high ferritin levels. So unlike people, in which you can have all different kinds of phenotypes of diseases, the dolphins had this one very clean type. And it was dolphins that were getting this combination of conditions that had the lowest levels of C15. So the same year we published this iron overload and fatty liver disease in dolphins in 2012, which was 14 years ago, researchers at Columbia University published a paper in which they discovered an entirely new way that our cells were dying called ferroptosis. And or maybe you would call it ferroptosis. I don't know, whichever way. We'll go with ferroptosis.
Yeah.
And so they discovered, and so they coined the term. So when we had our cell biology class, we learned that there are 3 ways that our cells die, and that was it. And now here they came out with a 4th entirely new way our cells were dying, called it ferroptosis. And what they described, Richard, is they said this method of cell death, which is very distinct, even just looking under the microscope, involved fragile fatty acids in the cell membrane that then led to increased lipid peroxidation, that lipid peroxidation combined with this mysterious iron that was showing up in the cells, when you combine those two, it created a massive production of reactive oxygen species, or ROS, which then took out the mitochondria. So the cell is intact, the nucleus looks normal, but all the mitochondria are gone and the cell is dead. And so they published that paper in 2012. Since then, there have been over 10,000 papers, peer-reviewed papers published on ferroptosis. We know that ferroptosis causes accelerated aging, faster onset of type 2 diabetes, heart disease, fatty liver disease, but nobody could figure out where did it come from and why was it happening in people. And then here, dolphins were telling us back in that same year that it was C15 deficiencies that were setting up those fragile, fragile cell membranes, lipid peroxidation. We can talk about the whole process of how the iron deposits, but I've been talking for quite a bit, so I'm going to take a breath and let you ask a question.
I was, but actually, I would be interested in the iron deposits, but with human NAFLD, do we see increased iron as well, or has anyone looked at that? Do we know?
Yeah, it's pretty fascinating. So it's not that, it's less that iron deposition causes NAFLD. It's much more, the story is much more that if you have NAFLD and you have iron deposition, you are far more likely to advance into a clinically relevant stage of NASH, of non-alcoholic steatohepatitis. That's where you get the inflammation, the lipid peroxidation, the cirrhosis, the increased risk of liver cancer, liver failure, and liver transplants. So it's like the iron serves as a line that allows the fat that's there to cross over from being inert and not harmful to something that results in, the number one cause or one of the leading causes of liver transplants today. So that iron serves as a catalyst to turn NAFLD from okay to really bad.
Right. So does the lack of C15 also increase the chance of iron deposits in the liver?
It does. And so here's how that works. And again, we were just so lucky to have the dolphins as this clean model, right? So, and patient population, we learned that from the dolphins, and again, this is all doing research, taking care of the dolphins. They were never used as research for humans. This is just a natural process that we were able to sleuth because of all of the wonderful data that the Navy had. So what we learned was that C15 makes our cells fragile, or sorry, C15 deficiency makes our cells fragile, is what's called, we're calling cellular fragility syndrome. This includes our red blood cells. So when our red blood cells become fragile, we have cells within our liver called macrophages, or Kupffer cells. They have a special name. And the job of those Kupffer cells are to wait for, one of their jobs is to wait for fragile red blood cells to come through the liver, and they take it out. They take out these fragile red blood cells, and then they recycle the iron and put it back into our system, which is fine until you have a whole lot of fragile red blood cells. And when that happens, the Kupffer cells become overloaded. The corpses that are left from too many weak red blood cells, the corpses that are left are iron. And when you get accumulating iron deposits over time, you get this iron overload. It sets up at the liver level ferroptosis, which again, it feeds for the dolphins, fed to metabolic syndrome. So insulin resistance, high cholesterol, it all really started for red blood cell deposition in the liver. Once if it got too advanced, that iron overload and ferroptosis and lipid peroxidation is happening in the liver, spills over into the bloodstream, and then it starts seeding other tissues. And that's where we know in people call this dysmetabolic iron overload syndrome, or DIOS. It spills over, it can then iron can seed the brain, our hearts, our pancreas. And there's a wealth of literature showing an increasing number of people with this iron overload disease affecting, all the things that we see with aging, but it's just more aggressive and happens faster.
So you would end up with iron overload and anemia at the same time.
Exactly. So this is something that, it's so good from as a physician, right? And of being able to understand, and there are more and more conversations being had about this, where you can actually have not just anemia, but you can have iron deficiency anemia in this syndrome. And it's
Right.
because the iron is getting pulled out of and being put in the tissues. That could
Right.
result in, when you take a blood sample, the blood itself may be deficient in iron, but the problem is it's all going into your tissues and you're storing up toxic
Mm.
levels of iron. So that's why now a full iron panel needs to include ferritin, transferrin saturation, so that we can have a better idea of making sure that a patient, whether it's a dolphin or a person, is not actually sitting on iron overload, and then treating them with iron, for example, to fix the iron deficiency anemia. So it's this careful balance. And again, a lot of people have iron deficiency anemia and do not have iron overload. So we're not saying don't take iron if you have iron deficiency anemia, but it's an added complicated factor that's just like one more level that, unfortunately now, because about 1 in 3 people have this metabolic syndrome, increasingly including this iron issue, that is really going to need to be included in assessments.
Interesting. Yes. Okay. We won't go further than that. So you've done a couple of that. Well, no, there's been a couple of human trials done with the C15 supplement.
Right.
So one of them was in obese young adults. So could we talk about that a little bit? And I saw that you saw kind of different levels of absorption in the group. Well, in the I guess the cohort that was taking the supplement. So do we know why that was? Is it something we would expect?
We had the same question. So this study came about, it was independently run by Dr. Jeff Schwimmer. He is a pediatric gastroenterologist. He's one of the world's leaders in pediatric fatty liver disease. So in fact, he opened the first fatty liver disease clinic for children back in the 1990s. So Jeff had actually read my paper on fatty liver disease in dolphins, Richard, like way back in 2012. And he reached out to me and he said, you're calling it fatty liver disease, but I doubt it's actually the same thing that we're talking about in the human world. So send me some liver tissues of dolphins. And we happened to both be in San Diego. And he's like, let me take a look at him under the microscope. So we sent him some liver tissue samples. And I'll never forget the email he sent back. And he's like, we are a go. He goes, this is exactly the same. He's like, so what's going on? Because we're pursuing sugar as a primary driver of fatty liver disease. He's like, dolphins don't have carbs in their diet. So that kind of turned Jeff on to looking at not just sugar as a contributor, but other factors. So he started looking at C15. So Jeff did a study in which he had over 300 kids, and he measured the amount of fat in their liver and C15 and fatty acids in their blood. And he showed, just like we had seen in the dolphins, that the C15 levels in the blood were inversely associated with the amount of fat in their liver. So he said, okay, this is interesting. So that then led to Jeff doing this clinical trial where he took kids that had graduated from his program. So they're now young adults with a history of fatty liver disease. They were his prior patients or existing patients. He gave them C15 supplementation. And that's where he showed that one, taking C15 supplementation successfully raised their C15 levels, and it was safe. That was really the primary intent of the paper, but he had secondary outcomes he looked at. And what he found was that for those people who took C15 and got over this threshold, this 0.2%, or in his study, it's equal to 5 micrograms per mil. If they got over that threshold, they saw the benefits of decreased liver enzymes, which makes sense for this population, because if you look at the baseline measurements of this population, they didn't have on average high glucose or high cholesterol. They had high liver enzymes. So it was great to see that it lowered their liver enzymes, but only if C15 got above these levels. So now getting back, Richard, to what you were saying, which is like, okay, wait, there was variation on C15 levels. And so the first thing Jeff looked at, he's like, listen, this is a population of 18 to 24-year-olds. So he's like, it's kind of like the worst population from a clinical trial adherence, adhering to a protocol standpoint. So they did look at, did they actually all take the 200 milligrams of C15 a day? And they did show that it explained about 80% of the difference is how well they adhered to the protocol. But there was enough difference. There's still a 20% left unexplained. So there does appear to be a difference in potentially absorption of C15. And so there's just going to need to do more studies to figure out this smaller subset. And were they overrepresented in this group? Because if indeed low C15 is a driver for fatty liver disease, we basically pre-selected for a group that may not absorb C15 as well. 2 out of 3 of the people in the study at baseline had what we defined as a nutritional C15 deficiency. So TBD, and did they need it for longer? Do they need higher doses? Those are really important questions. And it's good that there's a test available because if people are taking C15 supplementation and not seeing the benefits, one of the first questions is, gosh, am I absorbing it properly? So to be able to see it, like, are you achieving appropriate C15 levels would be a good first question for anybody not experiencing anticipated benefits.
Is there some upper limit to how much fat we can absorb at one go? So if you eat C15 with a fatty meal, would that reduce or increase the amount of absorption?
Oh, I'm so glad you just asked that question because yeah, it's a really good point. The amount of fat, really good point. The amount of fat we eat can influence our absorption of C15, at least based on mouse studies. So when mice are fed a high-fat diet, which they often are in order to induce disease states, there's often the high-fat diet induced obese mouse model. And what we know is that when mice are fed a high-fat diet, even though that high-fat diet has C15 in it, their C15 levels go down. And the hypothesis is that their C15 levels go down because, just like you were saying, Richard, that the body it's a competition, and for only 1% at the most, right? If 1% is C15 and the rest are these other competing fatty acids, yes, they could be more, they are more readily absorbed. C15 passes through without making a gate. So you just helped answer the question that possibly what we didn't look at in the study is, did these people were they on really high fat diets and at the time that they took the supplement, and could that have impacted their absorption? Hey, I think you're onto something.
So just a thought. I mean, for NAFLD, if you have NAFLD, what is the standard of care diet? Is it, I mean, I assume it's not high carb. Is it high fat, or do you know what they recommended?
It's so right now it's heavy emphasis on Mediterranean diet is probably gotten the most attention, and low carb, so sugars, they're told to, in general, decrease their sugars and the carbs. The fat, I think, initially was like, well, it's fatty liver disease, so don't eat as much fat. But now we're learning it's not as simple as that.
Right.
The Mediterranean diet, the other clinical trial that was done was in Singapore, and they had women who had fatty liver disease and had a high BMI. And it was really interesting study design. And it was 3 groups of women. The first group were put on a low hypocaloric diet. It is reliably shown that if you have NAFLD and you decrease your caloric intake substantially, you will see your liver enzymes get better. The problem, that like Jeff Schwimmer, because I talked to him about this, shared is that it's not sustainable. And he's like, it's not ideal to have somebody on a really low calorie diet for long periods. He's like, first of all, it's hard for someone to follow it. And he goes, and you're also not getting your nutrients probably that you need, right? So it does work. So their first group was a low hypocaloric diet for 3 months. The second group was a hypocaloric diet that followed Mediterranean guidelines. So Mediterranean diet. And then the third group was hypocaloric, Mediterranean aligned, plus C15 supplementation. And Richard, even I was kind of like, well, that's a big ask, because for C15 to do, because all the studies show it's going to do all these wonderful things, but can it do it above and beyond drastically reduce, basically weight loss caused by decreasing your amount, and plus a Mediterranean diet? So all three groups showed weight loss, which was expected because you're eating a lot less calories. The second group showed weight loss plus including decreased liver fat, and some improvements with regard to body. I guess it's all related to body weight. The third group had all of those things. And if you looked at trends, not significant, so it's important. If you looked at the trends, when you went to groups 1, 2, and 3, 3 had the greatest weight loss, 3 had the greatest loss of liver fat. So that was interesting, but again, not statistically significant. What was significant was that third group that had the C15 supplementation had lower LDL cholesterol, and it had an increased, these people had an increased growth of a microbiome, which is good for them for looking at the microbiome, of increased growth of Bifidobacterium adolescentis, which is this, which I didn't know about, but when I told Jeff lit up and he's like, if that's true, this is huge, because it's a microbe that is like a mama microbe in our gut whose job is really to help regulate metabolism. And it's been well established that people who don't have adequate amounts of this Bifidobacterium adolescentis have a higher risk of fatty liver disease and other metabolic diseases. So it was another interesting piece to the puzzle.
Yes. So you mentioned a test. So yeah, I mean, if people wanted to check how much C15 they have, so there is a commercial test available.
There is. And so since the 2000s, mid 2000s, most fatty acid panels now include C15. So, if for your listeners, if your doctor has access or uses a fatty acid panel, chances are that he or she could use that. They just need to make sure that C15 is included. Unfortunately, C15 is still being used as a reference fatty acid despite all these studies. And so it's not guaranteed it's included. So you need to make sure it is. Genova Diagnostics, we work with Genova Diagnostics to have a standalone at-home C15 blood spot test, so that if people didn't have, their physicians didn't have access to it, that this is another alternative where you can get this at-home test kit. You still have to, you bleed into some spots and you still have to send a test in and wait about 10 days for the results. But we did want to make sure that people would be able to really guide their C15 journey and help personalize their dietary choices if they choose to take a supplement by using this test as a guide.
Okay, and then you have a supplement. Any advice on how much or how often, with meals, not with meals?
Right. So we have, we always recommend, so we developed, this is all with the Navy. So all of this research that I talked about, for the most part, was funded by the Office of Naval Research. The goal was to develop a pure C15 ingredient that was safe, provided the appropriate doses needed. And really it was for the dolphins, for the dolphins to have a supplement. It ended up getting to us people first. So we always joke that this is no humans were harmed in the making of this dolphin supplement. So we recommend people take just start with a single 100 milligrams of the pure C15 and to try that for 3 months and get your blood work ahead of time or at least know your baseline blood work, and then get tested again at 3 to 6 months. The test isn't cheap. It's not, from what I've heard of other tests, I'm just not familiar with the testing cost world. That half of our customers since day one, we launched in 2021, half of our customers reliably report feeling better within 2 weeks, which was shocking because that was not the reason for putting C15 out into the world. It was for this long-term metabolic heart and liver health. We did publish a paper in 2022 showing that our bodies use C15 to make a second molecule, this metabolite called pentadecanoyl carnitine, or PDC. And we're wonderfully surprised, Richard, to find that our body makes this metabolite, use C15 to make this metabolite. It is the second ever discovered full-acting endocannabinoid. So it fully activates CB1 and CB2 receptors, which helped explain my own experience, but more importantly, reliably, we get from our customers of less joint pain, calmer mood, and better sleep. Because we're just like the mechanisms of action of C15, it just didn't make a lot of sense. And we're thinking this is probably placebo. But now that we know that this metabolite, that it may be differences in how well people make this metabolite might influence how, the half that feel the benefits versus those who don't. So I say start with one. And because we have such a high success rate, we have over 95% monthly retention rate with our customers, which is just unheard of in the supplement world. We know they love our science because we're all nerdy do-gooders, but they're feeling better. So a big reason. And I don't shy away from dairy fat. So I'm not C15 deficient, and I definitely feel the benefits of the pure C15, again, because it's not competing with all these other fats. I took the test and I have the Sardinian C15 levels of 0.46. So I do think it would be hard to have that high of a level or sustain it. So it's really, for me, a combination of foods. I do eat cheeses every day as a snack. And I have milk with my coffees, with my coffee and my fatty 15. And that, for me, that gets me to the right place.
Right. So as we kind of go towards wrap up, so what do you see as the future? So what research are you doing or you're aware of that's going on now, and where do you see this going in the future?
That's really exciting and hopeful, right? So we're doing research. We have a study right now that we're writing up a paper manuscript on, and it was looking at receptors relevant to Alzheimer's, treating Alzheimer's disease. So can't let the cat out of the bag on that one, but I'm really been excited about learning more about C15 and cognitive health. There's just a lack of literature on C15 and cognitive health. There are a few studies that are encouraging, but nothing like the high number of studies with metabolism, type 2 diabetes, fatty liver disease, heart disease. There are multiple meta-analyses on that front, really lack of them on the cognitive. So we're looking at that. So that's exciting. With regard to next steps for the C15 world, I really think increasing interest in, yes, help us stay healthy as long as possible, keeping our health, our modern health span, right, and applying that, but also looking at the front end and recognizing that we have more and more kids that are being born into the world and spending their first, critical decade basically C15 deficient. And that's because as generations have moved on, the younger and younger generations are increasingly not only avoiding whole dairy fat, they're avoiding milk, like dairy milk altogether. They've moved to almond milks and soy milks, and these don't have C15 in it. So if mom is C15 deficient, her milk is C15 deficient. And so we now know there are studies now being done by a really fascinating group of studies being done by other people showing that the more C15 mom has, the more she has in her milk, the more baby gets. The more C15 that baby gets, the better their body growth, the better their head circumference, indicative of brain health. And there's a group in France that's been following a population, a cohort out from pregnancy to the kids being 6 years old and showing that the kids with the highest C15 have better cognitive development and learning skills with regard to languages. So, gosh, it's, you think about fatty liver disease coming up out of nowhere. And now 1 in 3 people getting it, younger and younger people getting aging associated diseases of cardiovascular disease, type 2 diabetes, various types of cancers are all accelerating in these population that are in their 30s. This is about when dramatic changes were being made in taking milk away, even from infants and young children, at least in the US. So we've created deficient populations. So the big push right now is really having conversations like this, Richard, and bringing them, having the regulatory authorities, the people who are making the dietary recommendations, let's take a really close look at the science. And if there's a way to help fix and turn this around just by getting C15 back into diets, into infant formulas have no C15 in it, how can we help fix this issue, look deeper into it? And it gives you a lot of hope, because if, as a nutritional deficiency, the upside of it is that it's readily fixable. So we're excited to be part of that conversation and really helping to, help with industry practices and foods reporting the C15 levels that they have, so we can choose the foods with the highest C15. Lots of exciting things on that front.
Interesting. So where can people follow your work and what you're doing? And I guess, I mean, people can always search for C15 on PubMed, but for your specific work, where can they follow you?
Yeah, absolutely. So we actually put together, because it's hard for people, most people still, you have never heard of C15, let alone the wealth of science that you're on the cutting edge here to be able to talk about it. And now physicians and scientists are really tuning in. So in order to make it easier to help find the science, we are putting it all up at discoverc15.com. So every time there's a new study that just came out from Germany 4 days ago. Probably every 2 weeks, there's a new study from somewhere around the world on C15. We put a link to that at discoverc15.com. So you can nerd out all you want on C15 science. All the peer-reviewed papers are with regard to our product. We're at fatty15.com, and there's a lot of science in there. We have a TED Talk that kind of talks about the origin story that we covered here for C15. And then, like you said, going to PubMed, putting in pentadecanoic acid or C15. But we're trying to make it a whole lot easier by just letting folks go to discoverc15.com.
Excellent. Thank you. Yes, that would be very helpful. I had a look at Discover C15.
Oh, good.
It has the links.
That's great. And we do have in March, there's Simon & Schuster reached out, because we have a weekly blog. That's another way. If you go to fatty15.com, you can sign up for the newsletter. We have a weekly blog called Science Says. That's where we share the latest C15 news every Sunday. And so Simon & Schuster had been reading our Science Says blog for a year. And they said, hey, Steph, this is a book. Like, can you put all the science in one book? And I said, sure. So that's coming out in March. It's called The Longevity Nutrient, and it's over 300 pages of C15 science. So if you really want to sleep better at night, you can get the book in when it comes out in March. And Simon & Schuster is here to help you sleep better.
Okay, excellent. Yes, I will give that a read when it's available.
Excellent.
Okay, Dr. Venn-Watson, thank you so much for joining us today. It's been great talking to you.
Great. Thank you, Richard. It's a pleasure being here.
Thank you.